Great. Hey guys. So today our focus, or for this activity, our focus is really on the different types of transformations and if they are rigid or non-rigid. So we are going to answer a couple of these questions about a shape or a transformation, and then we are going to define, to determine whether that transformation is rigid or isometric or non-rigid. Non-rigid transformations result in a similar image. So our pre-image and our image are going to be similar, but they will not be congruent. They will not be isometric. So let us begin. All right, so here we have a translation. Remember for me what a translation is. You have a shape. Miss Monroe sticking to her triangles, and you slide it up, down, left, or right, or a combination of the two. You can slide it left or sideways and up or down to get like a diagonal direction. So the pre-image and the image are the same or not the same. So when we translate a figure, are those triangles the same triangle?
Absolutely.
Absolutely, I would agree. Those are the same. So I'm going to click on that on mine. If you wanted to make a copy of this yourself, go ahead. If you want to write this down on your own notes, feel free. If you just want to follow along, that's good too. All right, now we're looking at angles. Are the pre-image, or are the angles on the pre-image and the image the same or not the same? So our angles here is angle A and angle A prime. Are they the same or not the same?
Absolutely.
They are.
Absolutely.
Absolutely, they are the same. And then we have the orientation. Remember, orientation is the way it faces. So the top is still the top after I slide it. It's not going to be facing another direction. So is the orientation between the image and our pre-image the same or not the same? They're the same because that stayed the same, facing the same way. Remember, orientation is where it faces. It's a funny word for where does the shape face. So if our shape side lengths remain the same and the angles remain the same and the orientation remains the same, those two triangles are congruent. Those two triangles are isometric, and that transformation is a rigid transformation. All right. So now we're going to look at reflection. All right, a reflection. That reflection is taking the triangle and flipping it the other way, but you can't see the triangle on the back, but it is flipping it over the x-axis. That is that axis going up and down right here. So that is a reflection over the x-axis. So are our side lengths the same? Do those two triangles look pretty much the same? So I would click the same. Our angles, well, if it's an exact mirror image of our first triangle, I would say those angles are pretty much, exact. So I would say those are also the same. The orientation, so it's facing kind of the same way. But remember, if I had a different shape right there, let's see if I can get it on there. There we go. If I had a different shape up on that mirror, on that reflection, it does kind of change the way it is faced. Or if I reflect it this way, it is changing the way it is faced. So do you think that the orientation remains the same, or is it not always the same?
I don't think think it's always the same.
It is not always the same, correct? Because if it's the exact same, you can't get a real reflection of it. Think of it like if you're looking into your Zoom camera right now, or if you're looking into a mirror yourself. You look into the mirror. If I'm waving my right hand, you typically see your reflection's left hand waving back at you. Because it is a mirror image. They're the exact opposite. So after a reflection, it does change the way it's faced. All right, so this transformation, because the sides are the same and the angles are the same, we can say that those two triangles, even though they're facing different directions, even though that picture kind of makes them look like they're facing the same direction, even though they're facing different directions, you can say that they are in fact congruent, because congruent means same size, same angle, same size sides, same size angles, same size, same shape. So that transformation is in fact a rigid transformation. All right, here we are looking at a rotation. Remember, a rotation is where we take our shape and we turn it or rotate it around a point. Typically, that point is going to be the axis, but you guys got to experiment if you were to translate a point not around the axis, but you treat it the very same. You can't really use our algebraic proof that way, but you look at the point and go, okay, if I go up 3 over 2, I'm going to flip it and go up 3 over 2, just sideways. I personally even will turn my paper just to make it easier on myself. Yes, rotation. So the side lengths. Rotation does not seem to change the side lengths. And then we're going to talk about why in a bit. So a rotation does not seem to change the side lengths. So I would say they are the same. Angles. Our angles don't appear to change. My A is still an acute angle, my C is still that similar angle, and B is still the smallest one, so they seem to be the same. We will explain these things a little bit later. We will be drawing kind of a bunch just to explain why, but it'll come more in handy when we get to unit 3 or 4. 3 or 4 similar triangles coming up at some point after winter break or before winter break, around winter break. Anyway, our orientation. So if this is actually the triangle and we rotate it, the only thing you are doing is changing the orientation. So I'm going to assume the pre-image and the image are not the same orientation because they are in fact facing different directions. That is exactly what a rotation does. So our answers are kind of similar to the ones we have above. So our orientation is the only thing that changes. So our transformation, is it rigid or non-rigid? So isometric or congruent angles or shapes means same sides, same angles. And these do have the same side lengths and the same angles, so they must be rigid. All right, so far, translating is rigid, rotating is rigid, reflecting is rigid. Now let's look at dilations. Dilations, the side lengths. I can see right here that this side length and this side length are not the same. The green triangle is much bigger than that purpley pinky triangle, whatever color it is on your screen. So I can immediately assume that those are in fact not the same triangle. But we have angles. Angles are the pre-image and the image. Well, angle C and angle C, even though that line is longer, those two angles are going to be the same. Think of it this way. If I had like a little tiny triangle right here, it's a little right triangle, and if I grew it, it's still a little right triangle, right? Actually, that is not a right triangle. It does not have the little box. Now it has the box. If I have my little right triangle and I shrink it or I grow it, it's still a right triangle. Those angles don't seem to change. So I would say that our angles are not the same. Last but not least, we have orientation, and here we are looking at, again, which way it faces. So again, if I labeled that the top of my triangle, and I shrink it up, or I grow it really big, it is still the top. So the orientation is the same. So here we are with our last transformation. Is it rigid? Are these two shapes congruent? Or is it non-rigid? Are they not congruent? So here's when you really think, are these shapes the exact same? Could I say triangle ABC is the same as triangle A prime, B prime, C prime? So could I say that those two triangles are congruent or isometric? If I look at them, it's kind of tricky because I can tell that the angles are the same like we discussed, and the orientation is the same, but the size is different. So that makes it non-rigid. A dilation is non-rigid because the size is different. I cannot prove that line BC is the same as line B prime, C prime. I can prove that they're parallel. I can prove that they're proportional, but I cannot prove that they are the same given these two triangles because they're not. One of them is much larger than the other. So this transformation, a dilation, must be non-rigid. So far, rigid transformations, we have translation, reflection, and dilation. Oh, and rotation, not dilation. And for non-rigid, we have dilation.